Ano?
The second stage.
Pagkairo, bagyo.
Endogenic process. Endogenic process is manifested through deformation, magma, volcanism, earthquake, and metamorphism. What is causes of deformation? It is caused by tensional stress, shear stress, and compressional stress. Volcanism. It is a form of volcano. Magma. It is released or being released through volcano. Metamorphism. It is which may be shock, contact, regional, hydrothermal, and cataplastic. It is usually composed of the abundant elements including silicon, aluminum, iron, calcium, magnesium, sodium, potassium, hydrogen, and oxygen. Do you know what is the most common component is? It is silica. And the degree of resistance is called viscosity. Formation of magma. Magma is one formed under certain circumstances in special locations deep in the crust or in the upper mantle. Magma can be generated in several ways. Melting can occur when the temperature stays the same but the pressure decreases. This process is called decompression melting. This usually occurs in pools of the crust called rift valleys, mid-oceans, and in volcanic hotspots. Flux melting is when gaseous substances are added into the hot, solid rocks. And the water and carbon dioxide will react and weaken their bonds and cause it to change from solid to liquid. And the heat transfer melting is the melting of surrounding rocks cause it to melt over a range of temperature. The melting temperature of a rock is called eutectic temperature. And when a rock begins to melt, only a certain mineral are melted. This is called partial melting. And when during melting, it is called fractionation.
Volcanoes are the visible manifestation of the process of rock formation, as the ejection of lava or the molten rock that reaches the Earth's surface. The funnel-shaped depression where lava erupts is called crater. The event when the lava is spewed out of the volcano is called eruption. There are two types of eruption, the effusive and explosive. Effusive is dominated by the flow of lava and formation of fountains and lakes, while explosive is it ejects ash and larger fragments of broken pyroclastic materials, forming ash clouds that eventually collapse and cover the slopes of the volcano. Lava with low silica content are less viscous and flow more rapidly, generating effusive eruption. Effusive eruption is associated with lavas having high silica content and is more viscous. The dissolved gases in the magma develop very high pressure and rises towards the surface. There are three types of volcano according to its shapes: the shield volcano, the cinder, and the corpus. The shield volcano forms very broad dome with gentle slope that covers the very wide area. Example of it are the volcanoes in Hawaii. The next is the cinder volcano, are the granular materials formed by lava fountains. The last is the composite volcano, are composed of alternating layers of lava.
There are various types of materials formed during volcanic eruption. Effusive eruption from lava flow deposit. Lava with smooth surface are called pahoho, while those with very rough surface are called paha. Eruption could also produce pure volcanic glass called obsidian. Pumice is also made of volcanic glass but with frothy texture characterized by lots of open spaces caused by gas bubbles. Fragment materials of various grain size produced by volcanic is called pyroclastic debris. And lapilli are pale to marble-sized fragment of lava. Volcanic ash are very fine particles composed of glass shards, crystals, and fragments of existing rocks. The liquefied volcanic ash is called tuff. The blobs of lava that are thrown into the air and develops as streamlined and smooth-shaped fragments are called bombs. A paracastic deposit is the melted composed of pumice is called ignimbrite. When paracastic debris mixed with water, it forms muddy like slurry called lahar.
Earthquake. Earthquake is vibration in the surface of Earth resulting from the sudden release of energy. It could be a small shaking that could sway high objects, or very large movement that could destroy buildings and a catastrophic damage. The of rocks beneath the surface as a result of bonding process produces earthquake. Earthquake in rocks causes fractures to form. A form that is caused by an earthquake is called fault. Well, a fault is a fracture in which one body of rock slides past another. Faulting happens when the stress acting on the fault exceeds the frictional force on both sides of the fault. Focus or hypocenter, the place where rock fractures and slips. Epicenter, the point at the surface directly above the focus. The energy released from the hypocenter of an earthquake travels is the seismic waves. There are different types of seismic waves, distinguished in where and how they move. Waves that travel within the interior of the earth is called body waves. Primary waves or P waves are body waves in which the particles of the material move back and forth parallel to the direction of wave motion. Secondary waves or the S waves are body waves where the particles of the material move back and forth perpendicularly to the direction of wave motion. They are also referred as shear waves. Waves that travel along the surface is called surface waves. Well, there are surface waves that cause the ground to ripple up and down, and they are called Rayleigh waves. Lobs waves are surface waves that cause the ground to move back and forth in a snake-like movement. The seismic waves have different velocities, the P waves and the S waves. The P waves travel the fastest, followed by the S waves. The surface waves are the slowest one. The instrument that detects and records the ground motion from an earthquake is called seismograph. What it records is called seismograph. The seismographs consist of a heavy mass suspended in a spring and a rotating drum that records the motion. There are two types of seismographs. One that records vertical motion, while another records the horizontal motion. The size of an earthquake is measured in two ways. The number that indicates the relative size of energy released in an earthquake is called magnitude. It is determined from the maximum amplitude of ground motion recorded in the seismograph. Intensity. It is the amount of damage brought about by an earthquake, usually denoted as Roman numerals. The first intensity scale is called Mercalli Intensity Scale. It is developed by Joseph Mercalli in 1902.
Deformation. Tectonic force corrosion inside the earth causes rocks to undergo deformation. It is a process in which rocks change in shape, size, location, tilt, or break due to squeezing, stretching, or shearing. In physics, a force applied per unit is called stress. If the forces act uniformly from all directions, it forms uniform stress, also referred as pressure. The weight of overlaying rocks exert pressure referred to as piling stress. There are three kinds of differential stress: the tensional and conventional and shear.
2, 3.
First, tensional stress occurs when the dominant force is directed away from each other. It stretches the rocks, causing an elongation parallel to the direction of stress and shortening perpendicular
Deformation. Deformation is the resulting change in the rocks due to the different types of stress called strain. It is the change in size, shape, or volume of the rock subjected to stress. There are different kinds of stress. An object can become longer by stretching and can be shorter through shortening or contraction. Strain occurs when the change in shape involves movement in one part of an object relative to its other parts such that there is change in angles between features. Rocks can also temporarily change shape when subjected to stress, but can change back to its original form when the stress is removed. This is called elastic strain. There are three successive stages of deformation. When a rock is subjected to increasing stress, the first stage is a rubber band. The rock returns to nearly its original size and shape when the stress is removed. The second stage, it is the ductile deformation, in which the strain is irreversible. The rock is permanently deformed once it reaches the elastic limit. In the third stage, the deformation is also permanent, resulting to fracture. Rocks can be classified according to their behavior. When under stress, brittle materials have small region of ductile behavior prior to the stress but only small region of elastic behavior. Material behavior depends on factors such as temperature, confining pressure, and strain rate. Low temperature, low confining pressure, and high strain rate favor brittle behavior. Rocks found in the upper part of the crust behave in a brittle manner due to low temperature and low pressure. The rock deformed in a ductile manner due to increasing temperature and pressure. This is called the brittle ductile transition. Earthquakes occur only above this zone. The branch of geology concerned with the study of rock deformation is called structural geology. Strike is the compass direction of the line formed at the intersection of an inclined plane and a horizontal plane. Dip is the angle between the inclined plane and the horizontal dip. It is the angle between the inclined plane and the horizontal plane. The direction of dip is perpendicular to the strike. Joints are natural cracks in the rocks produced by brittle deformation. The rocks on both sides of a joint then slide past each other. Joints are formed due to tensional stress in brittle rock. It can form when rock collides and contrasts, or when there is decrease in pressure from overlying rocks. Faults are classified based on the movement of the rocks with respect to each other. In an inclined fault, the block of rock on top of the fault is called hanging wall, while the block below is called footwall. When the hanging wall moves down with respect to the footwall, it forms a normal fault. If the hanging wall moves up, it forms a reverse fault. A reverse fault with inclination below 333 degrees to the neocrystallization. It is the growth of new minerals that differ from those in the protolith. Pressure resolution refers to the dissolution of mineral grains when a rock is squeezed dominantly, dissolve mineral grains and precipitate elsewhere with the aid of water. Plastic deformation occurs when some minerals become flattened or
Neocrystallization. Neocrystallization is the growth of new minerals that differ from those in the protolith. Pressure solution refers to the distribution of mineral grains when a rock is squeezed. Dominantly dissolved mineral migrates and precipitate elsewhere with the aid of water. Plastic deformation occurs when some minerals become flattened without changing either the composition or crystal structure due to their plastic behavior when exposed to high heat, temperature, and pressure. What is the causes of metamorphism? Metamorphism occurs at temperature roughly between 200 degrees Celsius to 850 degrees Celsius. The temperature range between diagenesis form. Types of metamorphism. An intruding magma can cause metamorphism because of its high temperature and the presence of hydrothermal fluid. The magma cools but surrounding rock heats up. This process is called contact metamorphism.
Contact is because it involves existing rocks coming into contact with really intense heat, which is generally provided by lava or magma. So imagine that one day an intrusion of magma forces its way up through these layers of rock. Now, all of the existing rock are going to be burned by the heat of the magma. So all along the edge of this magma, shown here in orange, you're going to have rocks that have been burned by the heat of the magma. That burning causes them to change or metamorphosize into something new. So anywhere you see the orange, you're going to have some metamorphic rock. This is caused primarily by heat. Let's fill this in on our flowchart.
Metamorphism can also occur in sedimentary basins. Second type of metamorphism is a burial metamorphism. The third type is shock metamorphism, and the fourth type is regional metamorphism.
Let's imagine that I have a plate boundary here, a fault, a crack, and that these two plates are coming together. So it's a convergent plate boundary. Well, as you can imagine, in the middle here, there's going to be immense pressure, and that pressure can cause the rocks trapped in the middle to become metamorphosized. So all along this boundary, you'll find metamorphic rocks. Again, this is different from contact in that it's not so much about the heat, it's more about the pressure. Let's take a look at what we see here. This is a typical progression of metamorphism that occurs, starting with the sedimentary rock shale. If you add heat and pressure, it will metamorphosize to slate. If you add more heat and pressure, it will become phyllite, more, and it will become schist, even more, and it will become the metamorphic rock gneiss. Take a look at that gneiss sample down there. You'll notice it has bands of minerals. That's a result of the intense pressure. Now, if you were to take gneiss and add additional heat and pressure, it would likely melt into magma or lava, and then it would become an igneous rock. So gneiss is generally the extent of metamorphism that we see. Let's go back to our flowchart. So our second type of metamorphism is called regional metamorphism, and this is caused primarily by pressure. Of course, all of this is summarized in your reference tables on the metamorphic rock chart on page 7. You'll notice type of metamorphism, composition, what minerals are involved, how big the crystals are, whether it has banding or not, the names of the rock, and the map symbols. And of course, we'll learn lots more about this chart in detail.
These are the types of metamorphism.